Hey guys, how you doing? How's your day going? And if you're just starting, how's your night? Hope you had or having an amazing and a beautiful day. So today is day 4 of 100 days of Python. We still have a very long way to go, but we're getting there. So today we're going to be talking about Python list, and we'll be working with the random model also today. So I think this is going to be our very first model that I'm introducing it to you to in this series. I'm going to quickly let you know what a model is, and we're just going to jump in. So a model is it's a collection of functions that someone else has already created and made available to you, or it could be a collection of functions that you have created because maybe it's something you make use of a lot when you're programming. So all you need to do is just down you can either download the file, install the file. Some of them come inbuilt, like the one we're going to be working with today comes inbuilt in with Python as you're downloading it. You can create it and place in the same directory or inherit from the directory that is located in, and then access the specific function you want, because modules are usually made of multiple functions. We're going to that here quickly. So let me just so the model, when you want to access a model, if the model doesn't exist here, would usually install, like if it's not an inbuilt model and we want to get, especially for if we're using the Python index and want to access it from there, what we usually do is do run pip install. So I'm going to just show you how that works in a later video, but for today we don't need to install anything, so we're just going to import the directory because file already exists. So to do it, we're just going to say import. And I'm going to show you two different ways of importing. So we can import random because that's the model we want to access. So if we import random like this, if we want to access any of the functions inside model, inside random, we're going to have to say random dot the name of the function. And that one, if we want to import a specific function, we can say from random import. So then we'll call the name of the function we want to import. Or if it is that I want, like this method I usually use, if I want to import if I want to import a specific thing, I'll just, if I want to import everything, so I'll just use an asterisk. So if I've done this, if I want to access it, I don't need to put that random dot in front of the function I'm calling. And that way we can also use this from random import. Let's say we want to import a specific function, like one of the function we have random is choice. So I can say import choice as, and give the name I want to import as. So if I want to call choice, instead of calling choice, I'll call JH. This also applies when you can say import random as. So we're not doing this. So let's just import everything. It makes my code look like it's like some people, like I think because there's some functions you may work with that have, I don't know, honestly I've not worked with every single model that exists. I've not even worked with up to half of all the models that exist. But I wouldn't be surprised if there's some models that have similar names. So that's when you want to start implying import as, or just importing and calling the name of the model dot the function you want to access. But we're not doing that today. So there's a long list of random models you may want to look into. I'll leave a link to their documentation description below so you can go and check it. But there are three main ones that everybody like covers. So the first one is the rand int. So this rand int generates a random integer. So let's do it. So let's just print. We're going to print um sorry, rand int. Now the rand int takes it takes two arguments. So the first one is going to be like the starting range. Let's say we want to import from 1. And second one is going to be the ending range where I want to end at. Let's say we want to start from 10. So if you run, it's just going to generate a random integer every single time. So it generated 5 for us this time. Let's run it again. It generated 6 this time. So we're going to apply it into a program shortly. Let's say another one. So the next one is choice. So this choice, we're going to talk about list very soon. But this choice works with when you want to work with list. So let me introduce you what a list is. A list is a collection of different data types. And a list, when you want to define a list, you define it using a square brace. So let's create a new list here, and inside this list we're just going to call a square brace. So we can put strings, we can put boolean, we can put integers, we can put floats, you can put anything in the list. So let's just put a bunch of strings. Let's just put rock, let's put paper, and let's put, I think I'm not spelling correctly, but let's put scissors. Now, if I want to access this something in list, I can either print out the complete list by doing print and just calling the name of what I save the list as, the way you print any normal variable. So if I run it, it's going to print out every single thing that is present in my list. But what if I want to access a specific thing in the list? That's when you now get introduced to this stuff called indexing. So now in Python, because I just found out that SQL their indexing starts at one, but in a large amount of programming languages, indexing starts at zero. So rock is zero, paper is one, and scissors is two. I was supposed to draw out, like I had this chart I usually use when I'm going live, I'll draw out, but I forgot to draw it out, so I'm sorry. But this is zero, this is one, and this is two. This scissors is also negative one, this is negative two, and this is negative three. That's when you now start working with negative indexing. So let's print out using positive indexing. So why am I using curly braces? So if I want to print out rock, I'll just call zero because remember rock is zero. Run without debugging, you print out rock. If I want to call rock, I can also print out negative three. If I save it and I run it, I get rock also. So I hope like you have understood like the basic indexing and positive and negative indexing. Now this is other stuff called slicing. Slicing is where you want to print a range of integers. For example, if I want to print from the very first index to the last index, let's say I don't know how many things are inside the list, I can do this and just run without debugging. So it prints out the complete list because I say from one to this. What if I only want to print out the first two elements of my index? I'll just run without debugging. So it shouldn't print out scissors. Oh, sorry, sorry. Okay, because if you're doing like so, the way it works, it will print zero and one, but it will stop at two. I keep forgetting that. So it's not going to include two. It's going to stop at like it's going to stop right before you call two. I don't even understand. Okay. Now what if I want to like okay, this list is short, but let's just add another element so I can skip. Let's just add book. So what if I wanted to print after every, because right now we're printing after every, it's like the skipping, I don't know the right word. We're looping at one. I don't know the right word to use. But what if I wanted to print every two elements? If I don't know if what I'm saying is making sense. So there are three this thing you can take. So the first one is your starting point, second one is your ending point, and the last one is it the range, I think the loop. I don't know the word. Let's just put so I hope you understand. Like we'll print rock, skip paper, print scissors, skip book. Okay, let me print it to the end. Let me change this to, so you can see a printed rock, a skipped paper, a printed scissors. The reason why I left here blank because I wanted to print to the end of the list. Alright, so let's just take this out. What do I do? Okay, what else do I want to, okay, so this one, I don't know if you have ever seen a project when people be like, okay, let's print our stuff. You want to print a string, like there's a project where I think there's a project where they'll be like, okay, maybe we'll work on that when you print a string backward. Sorry, I'm having like a serious cold. Okay, so if we wanted to print our string in reverse order, so what we're going to say is first of all, we want to start from the beginning of the string and then want to print to the ending of the string. But now we're skipping. So if I put one, it's just going to be skipping everyone forward. But what if I want to start from the back? So I'm not going to put a negative one. So it's going to print my list starting in reverse order. Okay. Now let's go to our project. Let's today is day what? What is it? Today is day four. Okay. Let's just close this. Okay, so this is day 4. So let's add print string in reverse order. Okay, so the first thing, we're going to receive an input from the user. So it will not be as if we're the one who is controlling the output. Um, enter here. Then let's assign it into a variable. Okay. So once it takes the input from the user, what we want to do is a very simple program. We just want to print, calling the name of the list, the square brace from the beginning to the end, and skipping after every. I'm trying to save it. So let's run it. Without debugging. Let's say PRAISEESIARP, case closed. So that's a very simple program, straightforward. Okay, so I've introduced you to okay, I was trying to introduce you to traces. So now what this trace is going to do is going to pick a random element from the list that we've called. So I've given it a value of what we want it to select from. So it's not going to just choose a random thing from that list. So okay, so we're just going to call choice. We're going to have a parentheses, and in between the parentheses, we're going to call the list that want it to access from. So it's list. If you don't have a list already defined, we can just define like the list within this bracket. But sometimes it's better for it to like maybe have the list called ahead of time. Anyways, so every single time we run it, it's going to output something different. It outputted paper, run it again. The options is very few, so there's a very large possibility that give us something, but give us shrug this time. Okay. What else do you want to cover? Shuffle. Now this shuffle, unlike choice is picking a single thing. Shuffle is going to rearrange. I mean, you know what it means to shuffle a card. It's going to rearrange the list. So okay. No, no, I keep forgetting. All right. So now the order I printed it out as was paper, scissors, rock, which is obviously different from what we have in front here. If you run it again, it's going to hopefully be okay, scissors, paper, rock. So you're just going to print out random orders until you stop running it. And come on, find hard to they just took like now. Okay, now let's work with some of the should I tell you say actions or functions that can be carried out when you're working with a list. So I'm just going to cover a few. So I've introduced you to slicing. So what if you wanted to add something to your list? Let's just clean this shuffle out of here. And let's just print here, Jesus Christ. Let's just print from here so you can see the current list we have. And if you want to add a new item to the list, you can either, so there are multiple ways to go about this. So you can reassign it. Okay, I want to touch if you're valid. So let's just Okay, so I'm trying to think of things. Okay, so I'm going to introduce okay, if you want to add a new item to a list, maybe um you want to, okay, let's start by replacing a value. Let's start by replacing a value of the list. So if you want to reassign a value of the list, it's almost similar to what you do um when you're working with any other variable. So the first thing you want to do is find the exact location of where the list is. Let's say I want to replace rock, going to be equals to, let's just say van. So if we save it and we now print list again, so you can see the first one was rock, the second one was van. So that is reassigning. Now, still using the same thing. What if we wanted to like reassign like maybe the first two elements? So we'll say okay, the first one. So we're going to have to place it in a list now though, because the list we're calling. Anytime you slice something is a list that you're calling. So we want to replace the first one be van, the second one may be book. So if you save it and rerun it again, you can see it's replaced it van and book. Now let's clean this. Another one, what if we wanted to add a new element but wanted to add at a specific index? Because appending, so okay, let's append first. So if we wanted to append into the list, we'll say list dot append. So append only adds to the ending of the list. So if we appended book and we save it, is going to add it at the ending of the list. But if we wanted to insert to a specific location, we're going to make use of insert. The first one we're going to call is the index where we want to place it at, have a comma, and then we're going to call what we want to place there. So it works just like append, but it's going to place it at a specific index. So I don't know if you can see it here. The book is now at index number one. Now, if you have noticed, append, you can only add like a single element at a time. In insert, you can only insert a single element at a time. So what if we wanted to add like another list? So is there's this stuff called extend. So this extend is going to take another list also. So we can just add, let's just add a book and let's add something else, maybe cake. So if we save it and we run it, it's going to just add another list to the ending of where our previous list ended. What else? Okay, this extend doesn't just work on lists. You can also add any other data collection, even tuples. We'll get into tuples sometime later. All right. So now there's this other stuff like, let's say if you wanted to remove a specific word from your list. So first let's try removing a word that doesn't exist. Let's see what we're going to get. Let's run it. You're going to get a value error because you're trying to access something that hasn't been assigned yet. But if we remove something that already exists, let's say rock, and we just run it. Okay. Alternatively, if you want to remove an element using the index, so you're going to use pop. I feel like everyone should be familiar with pop. So remove is when you want to access the value of the index, while pop is if you want to remove the specific index. So let's say I want to remove the first element. So it should still be the same thing as the previous one we just ran. There you have it. Um, I'm trying to think what other things in list should you have. Okay, you can also delete a specific element from a list. That is, instead of having to make use of pop, so you can either delete a specific. Why do I keep? You can either delete a specific element or you can delete the whole list. So let's just um so you just call it the delete function. So if we delete a specific index, then it's just going to remove that specific word that's at that index. But if we don't call an index at all, it's going to delete the complete list. Okay. Another thing is, if you want to just, you don't want to delete the list, you want the list to still exist, but you want to delete every single value in the list. I know if the list is like a large list, you cannot be removing everything individually. It's just going to waste your time. Mhm. All right. So if you want to, all right. So if I was saying, what if you wanted to like keep the list, but you wanted to like clear every single element that was present in the list? So what you just do is going to be in the same method we're using before. You call the name of the list and dot clear. It doesn't take any argument, so you just run it. Okay. So I think that should be basically everything there is. So I mean there is more, but like these are all the basics. So let's just work on a simple project. Okay. So this banker roulette. So basically according to my the idea of the project is that you'd have a list of friends and you're supposed to choose who will pay the bill. So I have said since but I've not yet introduced you to like how to like we're going to upgrade this one. Now I'm going to like have you be the ones to impute the names of users you want to control. Because if you wanted to use it with your friends, I don't know your friends' names, I cannot program their name ahead of time. So I would want you to impute it. But we cannot do that yet because we don't know how to end how to like be receiving input and appending it into a list. So but I think there's something I can do. No, I'm not I don't have I touched loops? Have I introduced you to loops? No, I don't think I have. So let's just leave. Let's just we'll come back for this project. So let's just say assuming I already knew who all your friends were, and your friends were John, Mike, Paul, and that should be enough for now. And I wanted one of you so to pay. So I'm going to say print. For those of you who are just joining this, if I'm using a formatted string because it allows me to just be able to access my variables without having to like use all this comma plus and whatnot. So so what I say? Um, the bill or the tab, I think it's a tab they call it. The tab should be covered by curly braces to be able to access a variable, the name of the variable, and we want to print a random. So we're going to let's import our random here because let's import random. Import okay from random import as sorry import what's wrong with me import asterisk. So we want to print out is a random choice we're making, so it's going to be, let's just assign this into a variable, should we? So it's easier. So let's just say v is going to be equals to choice dot, oh sorry, the name of the list wants access, which is a, I think. So let's just print out v here. Control S. Let's run it and let's see. Okay, the tab should be covered by Paul. All right. So what should we do? Okay, so I said I think the next one, day five, we're going to introduce loops. So maybe after we do that, we'll come back and we'll work on these banker roulettes. But yeah, what else? Okay, so let me introduce you to this error. There's this error called index error. So like from all the errors I've worked with, you should be able to debug what this error is for. So basically an index error is going to be when you try to access an index that doesn't exist. For example, we have 0, 1, 2. So I'm going to get this error when I try to access 3. We have an index error. Now once you start working with loops, like I'm down the line, I'm going to introduce you to exception handling. So we're going to handle this exception. But if you want to be able to why did I introduce you to this error? I'm trying to introduce you to all the errors you can get whenever working with a topic, so that it will be easier when we start like trying to debug it. So just keep it in mind that it's an error called index error, and index errors are caught when you try to what do you call it, when you try to access an index, when you try to call an index that doesn't exist. So we're going to handle this error later, because right now there's nothing we can do with the knowledge we already have. But we're going to handle it down the line. So just keep it in mind. We have an index error and we're going to learn how to handle the index error. So um so we talked about nested what do you call it? We talked about nested if else statement last time. So now what if we have a nested list? So what is nested list? A nested list is just when you have a list within a list. So it's kind of like a multi-dimensional list. And we're going to see more of it once we start working with this. This model called NumPy. So we're going to see more of this when we start working with it. But for now, we're just going to do something basic. Let's do 1, 2, 3. So how do you think we're going to access rocks? I'm going to give you a minute to try and like print out rock. So just experiment with it. Print out rock from it. And okay, so if you got it, then congrats, I get. But if you didn't get it, so let me just, I'm going to break it down. So first we'll do, let's jump it, let's break this down into a new line so we can see it better, and like just do this. So I think I should use, let me use string, so it'll be better. Let me use string. Let me say pop. Let me say made. Ugh, I don't know what came to my mind. Oh, it's disgusting. Let's say ham. Okay, so I was trying to pick the word long enough so we can see, but you know what? Forget. So we have this one like this. This is index 0 within this list one. This index 0. This is index 1, and I'm going to prove that to you. If I printed out index 0, it's going to print out that complete list for me. You can see it, rock, paper, scissors, and likewise, if I printed index 1, it's going to print out the second list for me, and so on and so forth. But I don't want to get the complete list. I want to print out rock. So what do I do? So I've called the list I want to access already. So how do you think we're now going to go about accessing the second one? So if you remember, which is, I forgot what they call this stuff. Matrix in mathematics, you would be able to, like, understand it a bit better. But when we're working, so what about, I've called our very first list, which is the index zero, and within it, we want to access the index zero within this. So we're just going, even if there's another list enclosing it, we'll just be calling more boxes until we've gotten to the exact same point we want to go. And there we have it. It's like, it's very easy, really. And I'm not trying to say, oh, it's easy because I know it, but it's literally very easy. But if you don't understand it, then you can just ask the questions in the description below, and I'll be sure to explain it, in a much more detailed way, something that you could understand better. But yeah, let's build my very favorite project. I've like built this project so much that, like, it's disgusted by me. So rock, paper, scissors dot py. So the first thing we're going to do is, from random, import everything. So now the first thing we're going to do, we're going to have a list, and we're going to just call that list, let's say we just call it list. So this list is going to hold all the possible place the users can have. So it can be rock. I'm sorry, I'm just rewriting this message. I'm saying rock. Okay, let me just finish this. Rock, paper, see. Oh shit. Zos. Why is this word so hard to spell? Gosh, why is it so hard to spell? Scissors. When I was growing up, I used to spell scissors with Z. It was Scizzors. Oh wow. Ugh, I'm not surprised that is not the one that is correct, and what I'm right right now is wrong. So we have like the possible place user can have. Now, I'm sorry. Now we want to get an input from the user. So it's going to be, let's just call it user. It's going to be, I'm sorry, I need to repeat this message. Okay. User is going to be equals to input, enter here. All right. Okay. Now we want to now handle this error, because what if the user was to now pass in an input that was not rock, not paper or scissors? Well, firstly, the main error that I would usually get is, what if the user writes it in capital letters? You can see the things that are inside my list are all in small letter. So I don't know if you remember when we were working with string manipulation, we did this stuff where we called dots lower. We also need to remove white spaces, so dot strip. I think these are all the only things we need to handle. I'm coming. Okay. So we have made the whatever input user passes, we're going to turn it into lowercase, and we're going to remove all white spaces, both leading and ending. Next, we want to now check if user, you can say if user is not in, and pass the error first, but I'm just going to say if user in. So have I taught you this membership operator? So we have not in and in. In checks to see if it exists inside the list or the collection you're checking, and not in is if it doesn't exist. So if you use not in and the thing exists, it's going to return false. So if user in list, we're going to continue with our program. So let's just pass for now. Else, we're going to say print invalid play. Invalid play. All right. So this pass is just like, you want to collect this information, you want it to exist, but you don't want to do anything once it's tested to be true. I hope that's a good enough explanation. So now I've said if user is in list, do this, else do this. So next I want to now start handling all the games, because we need to generate a play for the let's say the computer. So let's say computer is going to be equals to, so I don't know if you can guess what we're going to use here. If you guess it correctly, congrats. Choice, and we're going to pass in list. So the computer has made their play, the user has made their play. Now we need to check who won. So we're going to say if if user is equals to, so the first thing I want to check for is equals to rock. Let's just do for the all the other ones to pass. Remember, if, because we want to pass multiple conditions. If user is equals to paper, pass. And if user is not rock, user is not paper, and user exists in the list, is going to be obviously scissors. And let's pass for now. Okay, so let's just copy this. Let's just copy this. Ish. So now let's start comparing it against the computer's own play. And just indexes. So it's going to be if computer, but if computer. So if computer is equals to rock, if user is equals to rock and computer is equals to rock, okay. So if user, okay, user is rock, computer is rock, so it was a tie. User is rock, computer is paper, you lose. You lose. And user is rock and computer is paper, you won. Okay, so I'm just going to copy this one we just wrote here now. I think, where do you stop at? Here. Rock, paper, and scissors. Now let's handle for, actually I need to space this, it's beginning to look too much in my eyes. Okay, if computer is equals to rock and user is equals to paper, it's going to be you won. But user is paper, computer is rock. Okay, if computer is paper and user is paper, it was a tie. Okay, and user is paper, computer is scissors, you lost. All right, let's come back again for it. Why do I keep getting attracted? Niggas, how can I expect this emotion? 1, 4, 3, love you. Niggas, okay, if user is scissors and computer is rock, rock wins computer now. You lost. If user is scissors, computer is, you won. And then this is, it was a tie. All right, so this should be everything. I think I feel I've covered everything. So let's run our program and just test all the possible errors the user can make. Let's enter rock with a capital letter. You won. Should it, let's make it print out. Let's make it print out the user's choice, the computer's choice. Print computer. Oh no, let's add a string here. It'll be weird if I just printed computer. Okay. The computer played Okay, so let's play something that doesn't exist. The computer played paper invalid play. Should the computer, you know what, you can move the computer's play down if you want the to handle the user's play first. I don't know. Do whatever you wish. None of my business. Alright, yeah, I think that's everything. Let me see. Yeah, that should be everything. If you have any questions, leave them in the comment. Don't forget to share this video to anybody you think the video will be helpful to. And I'll see you guys here tomorrow. Have a nice and beautiful rest of your day. Bye, guys.